Hi, I'm back. Okay, I'm continuing my lecture, trying to wrap up chapter 2, and I just posted video number 8. Here comes video number 9. Okay, now one correction I want to make. I walked you through what happens when you compound more often than 1 year, semi-annual, quarterly, and monthly. I gave you the results here. The more often you compound, the greater the number you'll get, the more your money is working for you, okay? And I made a mistake. At 10 minutes and 18 seconds, I made the comment divide by 2, multiply by 4. That was clearly incorrect. When you're dealing with quarterly mathematics, you divide the annual interest rate by 4, not by 2. Okay? And still multiply by 4. So if you're dealing with 1 year, you would use 4. You'd multiply it for 4 periods. 2 years, it would be 8. 3 years, it would be 12, obviously. So I apologize for that. Please make sure you make a note of that. Okay? So, now I want to emphasize, ladies and gentlemen, that everything we did in the last video applies to all 4 of the tables, okay? If you're doing anything in increments that are less than a year, that applies to all of the tables. The more often you compound, if you're an investor, the better that the time works for you, okay? And that also applies to trying to find how much you will owe if you are calculating a monthly payment and such things. We will get into that, don't panic quite yet, okay? So here's a quick demo for you. Let's use present value. Now, what we did in the previous example with $80,000 is we said, what will it be worth moving into the future at 12% annually for 3 years, okay? Now, what we did is we turned that into semi-annual, quarterly, and monthly compounding. This time, I want to move backwards through time, and we'll use, therefore, table number 2, a single amount. So here's my example, guys. What if you want to have $50,000 in 4 years and you can make 8%? That's easy. We know how to do that. We're going to use table number 2. There's table number 2 right there, okay? Present value of $1, a single amount, one time only. Now, okay? Now we know how to do that. How much? The question is, how much do we invest today? Okay? I want to have $50,000 in 4 years. So if interest compounds annually, table 2, present value, we know what to do. We're going to take $50,000 and multiply it by 8%, 4 years, there it is, 0.735, okay? So the answer to that would be 0.7350 multiplied by $50,000. And it didn't work. Hold on, 0.7350 times $50,000. Yes, I've only used this program for decades. There it is, $36,750. Okay, so to have $50,000 in 4 years at 8%, I would only need to invest $36,750 today. Okay, so now here's my question. That's assuming that your money only computes interest on interest once each year. What if your investment compounds more often? What about quarterly? Okay. So we're going to do it again, and this time interest will compound quarterly. All right, the magic number is 4. There are 4 quarters in a year. So you say to yourself, okay, 8%, all right, divide 8% by 4, that's 2%, okay? Then I multiply the number of periods by 4, and 4 times 4 years is 16 periods. So there's the new and improved information I will use, ladies and gentlemen. I'll use the same chart, the present value table, table number 2, but this time, instead of using 8% for 4 years, I'm going to use 2% for 16 periods, okay? So come back to the chart here. 2%, there it is, it's going to be in column D. 16 periods will be 0.7284, okay? So 0.7284 multiplied by $50,000, the amount that I want to have, is going to be, and let's math it out, 0.7284 times $50,000. Okay, no, that didn't work. Let's try that again. 0.7284 times $50,000. And bear with me. There we are, 36,420. Now let's stop right there and explore that. Up here, compounding annually, we needed 36,750 to grow to $50,000. Okay, Here, and I'll make this a different color for us, we need less money, 36,420. Why is that? Well, think about it. It makes sense. If we're going to compound more often, in other words, put the strength of compounding to use more often, it makes sense that we don't have to start with as much money, because the money we do start with will work harder for us than with annual compounding. So, okay, if we start with less money, it makes sense. So what I'm going to do is I'm going to prove it to you. Okay, I'm going to start by putting down my years. So I'm going to take 1 year plus 1, and I will do that 14 more times. All right, there we are. I'm just going to insert 1 more year and carry that down to 16. There we are. So 16 periods, okay? So now let's take the number I think I need, 36,420. Now that money is going to work for me. How often? Now please don't make the mistake of using 8%, friends, okay? Now what we're doing is we're working on quarterly compounding. That means we're going to use 2% per quarter, not 8% per year, okay? So I'm going to take how much I start with. I'm going to get to the end of the first quarter, and I'm going to multiply that by 0.02, and at the end of the first quarter, I'm going to have 36,420 plus 728.40. I will now have 37,148.40 after 1 quarter, okay? Now this is the same logic I've used in all my proofs for you so far. I'm going to take those numbers and replicate them for all 16 periods. There, ladies and gentlemen, is my $50,000 of a little rounding difference. I don't care about that, okay? And that's how it's done. So there's my proof for you. I hope that you found that satisfactory. Okay? All right, very good. Now, a common question I get at this point is, what table should I use? Okay, this is very common. And after a while, friends, when you deal in finance and accounting, you're going to find that your selection of the table, your use of the table will become quite instinctive. However, let me get you started. Let me jumpstart you, okay? Here's the secret. You're going to use a process of elimination. You're going to ask yourself 2 questions. You're going to say to yourself, first of all, am I moving forward through time on the timeline, or am I moving backward? Okay, now I've got 4 tables. So if you say to yourself, on the timeline, I'm moving forward, then it's either going to be table 1 or 3. Okay? Now, if on the timeline, I'm doing this for you, this is forward, now we're moving backward. A future value to a present value. If you're looking for a number moving backward on the timeline, it's got to be table 2 or table 4. Okay? So right away, once you answer that question, am I moving forward or backward, you know it's down from 4 tables to 2. Okay, now you say to yourself, here's the second question. Am I dealing with a single amount, one-shot deal, one time only? Or am I dealing with an identical stream of periodic payments? Okay, now, if it is a one-shot deal, forward or backwards, it's got to be table 1 or table 2. If it's a series of identical payments, a shortcut in other words, it's got to be table 3 or table 4. So by asking these 2 questions, ladies and gentlemen, you're going to nail it, okay? So that's the secret. After a while, you won't have to ask yourselves those pesky questions anymore. I hope that's helpful to you, and I will save that for you, okay? All right, very good. Let me see if I've missed anything by going through my slides here. Okay, now the next topic that we're going to discuss is one of these questions, friends. Now, up until now, we have solved for pretty much 2 unknowns. Either a future value given a present value, or a present value given a future value. It's always been FV or PV, or FVA, PVA. Okay, of all of those factors, there are 3 other questions you might have to answer. Number 1, how much time is involved? Number 2, what is my interest rate? That's a common one, because whenever you invest, friends, you're going to want to know, how much did I make as a percentage? Okay? Because you can walk right down to Dean Bank and invest and get a fraction of a percent for your money. But if you invest in something riskier, risk and return, chapter 1, remember? You want to make sure that you're being compensated for that with a higher rate of return. You want to know your interest rate. Number 3, and this is a biggie, guys, you want to know the amount of a payment. Okay? Now, when I was a little boy, I remember my dad bringing me in the late 50s to a bank, and he was applying for a loan. And he wanted to buy a house for $8,000. How lame is that? Okay? And given the amount he wanted to borrow, the amount of time, a 20-year mortgage, and a percentage rate, okay, the banker, before the years of financial calculators and personal computers, was able to tell him immediately how much to the penny he would have to pay every month. Whenever you borrow money, you want to know what your payment will be. Okay, that's the third unknown. Given a series of payments, knowing how much you owe, and the interest rate and the time involved, okay, what will be the amount of the payment? Now that's something you want to know because you have to budget that. So the banker would pull out this. I got this in 1975 or 76. This book is about 2 inches thick, and it contains nothing but numbers, okay? And the banker would pull this out, and miraculously he or she would say, oh, you're going to owe $278.18 every month, Mr. Adams. Whoa. Okay, it sounded mysterious. It sounded like that person was Merlin the magician. It's a lot easier than that. It comes down to simple math, okay? So we don't need these things anymore. One of these days I'll sell this thing to the Smithsonian, I hope. Okay, along with my Peter Frampton record. So, of all of the variables we've had in the 4 formulas we deal with in this course, the only ones we have not solved for algebraically are the time, the interest, and the amount of the payment. Okay, so the remainder of chapter 2 is going to be dedicated to those unknowns, and I am on page 36 and 37 right now, guys. Okay, so let's go back to our slides here. Now, here's a common one. Solving for the interest rate. This is number 2 of the 3 I just gave you. Now let's assume that you bought stock for $2,500. You bought it 5 years ago. You just sold it for $3,500. Okay, now remember, right now is the future value. We are in the future because we bought the stock in the past. We have to move, from your perspective, from what we know now back along the timeline. Okay? All right. So here we bought it for $2,500. Now it's worth $3,500, and the time span is 5 years. Now, you need to know one of the 2 factors in the tables. The tables are time and rate. Here I've given you the time. What do we not know? It was a one-shot investment, as I say here, and you earned $1,000 bucks. 3,500 minus 2,500. Okay? You want to know what the rate of return your investment gave you. Okay? Now, what do? You solve it in 2 steps. You derive it from the tables. Okay, now, of the 4 formulas we used, the simplest one, the most basic one, was number 1. FV equals PV times the table 1 value that we call the FVIF, the future value interest factor. So when you substitute into the equation, what we know, 3,500 equals the present value, 2,500, okay? Don't use the word present. It was what we started with at the start of the timeline, times the FVIF. We don't know the FVIF, okay? We're about to find it. So by algebra, we divide both sides by $2,500. That means we get FVIF on one side of that equals sign, and that means solving for it, we get 1.4. Okay, now that's step 1. We don't know our answer yet. We're trying to find the interest rate. Okay, but we know the FVIF. It's 1.4. So what we're going to do is go to table A. Why table A? Why table 1? Because I used formula 1. FV equals PV times FVIF. Okay? I could have solved it using table 2. No, I like using table 1. So whenever possible, let's use table 1. So I'm going to go back to it. Okay? So 1.4. Now I know the FVIF is 1.4. Now, there are two factors that make up that FVIF. Time and the rate. I'm trying to find the rate. I need to know the time in order to find it. I know the time. It's 5 years, right? The preceding slide. 5 years ago. So, if I therefore go to table number 1 or table A, I'm going to look for that 1.4. Where do I look for it? I'm going to look for it in this row. Now what you do, friends, is you scroll across. You know it's got to be in this row. Whoop, there it is. Look, that's about right. Now, there is a way to find exactly the interest rate. It's called linear interpolation. I'm not going to burden you with that. I never do it in any of my classes. What I want to do is come close. When I ask you a quiz question or a homework question, I want you to come close. My question will say approximately. Come as close as you can. It appears that 1.4026 is the answer. Therefore, it's in column I. The answer must be, therefore, 7%. Okay? So there's the slideshow. Okay, table A includes two variables. That should be variable plural. Let me fix that right now. My apologies for the typo. You can't solve any of these problems for both time and interest. You have to know one of them. In this case, we knew the time. Using it, we found the interest rate. It was 7%. We scrolled across with a ruler, with your finger, whatever, until we got to 1.4026. Close enough. The answer is approximately 7%. Okay? All right. Now, using the same principle, ladies and gentlemen, we just solved for the interest rate. This time, we solve for time. We use the same method. Okay? Let's see what happens. All right. Now, this time we have to know the interest factor. You need to know, I have to give you the present value, the future value, and either the time or the interest. This time I'm going to give you the interest because we're solving for the time. So you can invest 15 grand today at a guaranteed rate of 5%. Your goal is to have 24,450 at some future point for whatever reason. That's your goal. I want to grow 15 grand to 24,450, and I know I can lock in 5%. My question is, what will it take to get there? Okay, that's a fair question. I'm going to use the same formula. I love using the simplest formula, Formula 1, Formula A, FV, PV times FVIF, just like I did a moment ago. I'm going to plug in the numbers I know. I take my future value, okay, 24,450. I plug in my present value, 15,000. I don't know FVIF. Step 1 is to solve for it. Step 2 will answer the question. All right. I scramble my algebra as always. I divide both sides by 15 grand and I get an FVIF equal to 1.63. There it is. Step 1. I know my FVIF. Now I go to my table and I know that my rate is 5%. So this time I go to the column and I scroll down until I see something that's about 1.63%. Here's my timer. I'll finish in a moment. 5%. I go down and I see that number. That's pretty much it. 1.6289. And that is 10 years, 10 periods. Okay? All right. So that means my answer is approximately 10 years. Okay? Now, when I come back, my time is up. When I come back, I'm going to take those two problems and I'm going to show you a quick proof. Okay? Stand by. I'll be back to you momentarily. Take care.